right. Welcome, everybody. Hey, Scott, how's it going?
Hey, Steven, dude, it's going good. Stoked to be here.
Yeah, thanks for joining us. Um, so, if anybody is just watching for the first time, we're going to go ahead and before I introduce Scott here, I'm just going to kind of give a little lay of the land here in terms of this Bitcoin mining hackathon that we're putting on, and let you know everything you need to know about that. For anybody who has been following the streams, things might look slightly different. We had some technical difficulties with our previous streaming provider, so we kind of put this one together at the last minute, but the show must go on. Um, so I'm going to go ahead and just talk a little bit about this event. It has been running since last Saturday. It's called the Battle of the Mine Hackers. This is a global event that we've been running out of ATL BitLab, which is a freedom tech community space in Atlanta, Georgia. And if you want to get involved, really the best way is to just join the Discord, because when you join the Discord, you're there surrounded by mentors such as Scott, as well as all the other hackers that are working on stuff related to mining. And the overall theme of this event is to get people excited about working on projects that fight miner centralization. We're talking about centralization of hash rate and pools, centralization of block template construction, and also centralization of hardware manufacturing, which Scott can tell you a lot about today. We have some sponsors I'd like to thank before we go any further. At the terahash level, that's Clean Spark, the gigahash, that's Pleb Lab and Hash League, and then our community sponsors, Choya Inc. and Cryobyte. And we have three different prize tracks here for this event, and a lot of times we tend to think of a hackathon as being something for writing code. And of course, this one's no different. There's certainly a lot of code that needs to be written for miner decentralization, talking about working with stuff like Stratum v2, projects like Hashpool, all of that good stuff. But we also have tracks for hardware as well as energy. So the energy track is stuff like, heat reuse and novel energy sources for Bitcoin mining. And the hardware track is like working on open source mining projects, stuff like the Bitaxe and some of the other stuff that they're cooking up at the 256 Foundation. And so each track, there's going to be a winner in each track here. We got a 1.5 million sats prize, an ATL BitLab social pass for 1 year, and a Cryobyte S19J Pro cooling kit for each one. There's also a sponsor challenge for Hash League for the best new addition to Hash League. If you'd like to add Stratum v2 to that, somebody, I would love to see that. Cool. We have an awesome panel of judges here. Scott is one of our judges as well as the mentors. And there's several other mentor sessions coming up over the next coming weeks here. So you can find the schedule on the website here. Some of these are things that you watch a live stream of. The other ones, some of them you can join us in person at ATL BitLab. Like for example, this Saturday, we're going to be breaking down some Antminer S9s together and learning how to work with those. And then some of these will be like jam sessions where you can get feedback on your work. You can either join in on the voice chat on Discord or join us in person at the lab for those. So a lot of different ways to get involved at this hackathon. You don't have to be in Atlanta. This is a global event. And so we love to see participation from all over the world. So yeah, with that being said, I think I'm going to just go ahead and introduce Scott and turn things over to him. So Scott, I've known from the Bitcoin mining scene. We met at a conference earlier this year. And even before that, I had been running some Bitaxes out of ATL BitLab here, just trying to learn more about mining, myself as I became interested in this problem of miner decentralization. And so, since hardware is an important part of miner decentralization, I thought there'd be no better person to get involved in this project as a mentor, since he kind of kicked off the Bitaxe project. So, Scott, I'll thank you so much for joining, and I'll let you take it away from here.
Okay, right on. Well, thanks, Stephen. Thanks for having me here. Also, thanks for putting this hackathon together. This is a fantastic idea. I was really, really excited when I saw you guys were doing this, and then especially that it had a hardware track. As I'm going to talk about today, I think that miner hardware centralization is a really big problem, and so we need to have a lot more people learn about this, get involved with it, start doing things, whether this is hobby projects or businesses, because we've got a lot of work to do to decentralize this. So anyways, this hackathon is fantastic. Hopefully I can inspire people to play around with it. It's maybe intimidating at first, but that's not how it works. It's not that hard. So like Steven said, I'm Scott. I'm a hardware hacker. I've been involved in hardware for a long time. I'm an electrical engineer by training. More recently, I got involved in Bitcoin mining and decided to make my own miner. So I started the Bitaxe project as a kind of futzing around with this and to see if I could do it. And luckily, lots of other people in the community also thought this was an interesting idea and joined up on the project to help make the Bitaxe a reality. It definitely is not even close to all of my doing, but I guess I started it. One of the things that I've learned getting into this is that Bitcoin mining is tragically centralized. And so I'm very passionate now about decentralizing Bitcoin mining and doing that with open source. I'll talk some more about that. But one of the key takeaways here is that like we can do something about this. Hardware is hard, but we can do it. We've got to do it. We must do it. And so this picture I've got on the screen here of this Bitaxe, I thought was pretty cool. Someone just randomly posted this on Twitter, and I thought it was neat because this is like this sort of just the simplest mine hack you can do, right? They took their Bitaxe and they nailed it to the wall. You can see there's just like 4 nails holding it up. It's totally fantastic. We can just do things. How cool is that? I think this probably wouldn't be the most popular entry in the Mine Hackers Hackathon, but it shows that you can start anywhere. And yeah, let's get into it. So like I was saying, Bitcoin mining tragically centralized, and I think that this undermines the core principles of Bitcoin itself. So there's a bunch of different aspects to Bitcoin mining, but we have mining pools. And like Stephen was saying earlier, they are very centralized. This is a massive problem. I think we're going to actually hear from some people as a part of this hackathon, these seminars about people working on this. So I'm not going to really get too into that problem, but just so you're aware, mining pools, very centralized. We also have centralization in the hash rate. This is like where the machines are physically located. Public miners, these are like huge publicly traded companies on the stock market. In the US alone, these publicly traded companies control 30% of the global hash rate, which is cool. Like, they're mining Bitcoin, but 30% of the hash rate is controlled by executives, investors in these companies, and probably more importantly, the governments that regulate them, right? If you're a publicly traded company, you have to follow the law. Your investors will demand it. If right now it's legal to mine Bitcoin, maybe that changes. And so the governments have a pretty oversized say in what a large portion of Bitcoin's security budget, how it operates, which I don't know, kind of sketchy. We have what I wanted to talk about today, which is the hardware centralization. This is a really big problem. You can see this picture here. I got this out of Bitcoin magazine. Bitmain controls 80% of the hardware market. That is ridiculous. That is so much. One company controls that. And even crazier is that second one, WhatsMiner, which the company is actually called MicroBT. But that was started by Bitmain executives. It's essentially a clone of Bitmain. MicroBT makes the WhatsMiner. And so, I don't know, it doesn't seem like a very good alternative. I think they're just competing against each other, making the same thing. And I would assume have the same sort of goals as far as control and centralization of Bitcoin. So we're looking at, was that like 93%? Essentially under one roof. This is not a good thing at all. Why is this a problem, though? Centralization in mining sucks because Bitcoin is supposed to be open source. It's fundamentally open source. Satoshi said it himself in early 2009 when he started Bitcoin. This is the first ever public post, I believe, announcing Bitcoin. It's right there in the subject header of this posting. He says, "I've developed a new open source peer-to-peer eCash system called Bitcoin." It's right there. And I think that this is why we're all here. This is, this is why Bitcoin exists, why it still exists. Had Satoshi decided to make Bitcoin a proprietary project, maybe it's Microsoft's going to run it or whatever, it wouldn't last. It would have been shut down long ago. We wouldn't be here. So one of the big reasons why we're here, one of the big reasons why Bitcoin is where it is because it is open source. It's decentralized development. And so, like I was saying before, 80% of the mining hardware in this, fundamentally decentralized project called Bitcoin runs on proprietary closed source firmware, and they're even more proprietary hardware. Like if Bitmain sneezes, Bitcoin catches a cold. We don't have transparency on how this works. We don't have any control over how this works. We just have this like single point of failure that is Bitmain. That would be fine if Bitmain were a trustworthy company, but they're not. They actually have a long, tragic track record, which we'll get into here. It's not so good. We have sort of their first, big sketchy move was called Antbleed. This is in 2017. They added a backdoor to their firmware where they could remotely shut down miners. So this is a miner at your facility that you own, that you're paying to run, that is mining you Bitcoin. And Bitmain secretly added a backdoor to it where they could shut it down. And there's not really much you can do about it. They didn't announce this. This was discovered by researchers who were poking at it. The firmware isn't open source, so we can't see how it works. They certainly didn't announce it. And so researchers kind of had to get in there and reverse how it was working and dig into the firmware, and they could see that this feature was in there. Bitmain was pressed on it, and they kind of gave a weak-ass excuse that was like, oh, this is... so we can recover stolen miners, blah, 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 blah. Bad excuse. They walked back the changes and got rid of it, but is kind of a first example of like them not acting in the best interest of the Bitcoin network and the Bitcoin miners. 2017 was a big year. We also got ASIC Boost, which was originally it was a discovery to increase the efficiency of Bitcoin mining. But the sort of sketchy thing here, the scandal, was that Bitmain implemented this in their ASICs and didn't tell anyone. And they only enabled this feature for themselves in the miners that they were actually running and didn't tell other people about it for a while. And they went through kind of insane measures to cover this up and to kind of hide this from their customers and from the public. There was this like overt and covert ASIC boost, different strategies of doing it so no one could notice this was happening on the blockchain. Totally sketchball. It's huge drama. They actually, I don't know why, they actually eventually ended up releasing this for everyone. This is now a standard feature in all miners, this ASIC boost thing, but it had a sketchy origin. Last year, there was a bunch of drama about Bitmain machines mining empty blocks. This kind of takes away fee revenue from miners when an empty block is mined. It's a little bit of a technicality that happens right when a block is solved. There's a new block, and when it was taking Bitmain miners too long to switch over to the new work. So pools were trying to overcome this fact by sending empty blocks that were faster for the miner to start working on when there was a new block. And then the miners kind of held on to that empty block for longer than they should have, and were working on that. So as a result, there was several pools were mining lots of empty blocks. A bunch of drama about that. This could have been easily resolved had we had some sort of insight into how the firmware works, some sort of control. Like clearly there's people who could have fixed this issue like right away. if it was just an innocent bug kind of thing. But we don't have that ability. We don't have that ability to see how the firmware works, unfortunately, for now. There was some weirdo thing that was happening like 2 months ago now with Stratum broken. Like it just wasn't working. The Stratum client implementation on Bitmain's firmware was not working with certain pools. Like what the heck? That's ridiculous. Can you imagine if you're running a multi-billion-dollar mining company and you run a firmware update that just takes you offline? Like you're just sitting there offline. You have a power purchase agreement, so you have to buy the power whether you're running your miners or not, and now they're not working. Like that's a massive counterparty risk. I cannot believe that investors in a multi-billion-dollar company would be very happy if you told them, oh yeah, we're completely reliant on one centralized entity that totally controls our main method of revenue generation. That's weird. And again, this is probably about a month ago now, but we had some machines that went out of the factory with a test firmware on it that was potentially hijacking hash rate. I don't know if anything really ever got made about this. It seems like it was a mistake in the factory, an oversight. But again, this is big business. A lot of people are very reliant on this, and you know, there's not really anything you can do about it. Like if the mothership messes up, we're all just screwed. So there's a lot of problems, a lot of downsides to relying on this kind of thing. All right. So open source is Bitcoin's superpower. In my opinion, it is what makes Bitcoin so freaking fantastic. It lets us contribute, audit, and fork around bad changes. If there's something that just someone doesn't want to run, you can see that it's in there. You can change it. This is how Linux works. This is why Linux powers like the entire internet. Maybe not working so well today, but this is what powers the internet. But also think Bitcoin Core. Bitcoin Core is an open source project. Bitcoin Knots is a very good example. There was some people that didn't want to have a particular change, and they could just, essentially be the change they want to see in the world and fork Bitcoin Core and run it how they want. This is what gives us optionality and freedom to run this thing how we want, how collectively we want to run it. Closed source, however, closed source hardware and firmware, it locks us out, right? We can't make contributions. You have to get a job at Bitmain if you want to make a contribution. We can't see how it works. We can't audit it. There's no way to fix egregious changes. If Bitmain decides something's going to be done a certain way, there isn't really much we can do about it. This is why Bitmain's dominance is so dangerous. It is anti-Bitcoin. Bitcoin is fundamentally permissionless, decentralized, and censorship resistance. And being centralized breaks all that and is very anti-Bitcoin. So we need to reclaim the open source advantage here in mining, and that's exactly what we're going to do. That's why we're all here. As I was saying before, you don't have to be a genius to do this. You can figure it out. You can learn, and let's do exactly that. But one of the things I wanted to touch on briefly is well, who cares? Like, why do we need to do this? Isn't this just about making money? Like, as long as number goes up, aren't we fine? Like, Bitcoin's way up. It's up and to the right constantly. Like, who cares? We don't need to fix anything. It's working just right. Well, no. Bitcoin is number go up technology, price go up technology. It seems to be doing that pretty well. That's fun. That's profitable. But I think what is potentially, or it's definitely more important, is freedom go up technology. According to the Human Rights Foundation, over 50% of the world lives under authoritarian rule. Bitcoin being fundamentally decentralized, permissionless, and censorship resistant makes it a critical tool for human rights. These 54% of the world, these are people that live with corruption, kleptocracy. They can be thrown in jail arbitrarily, forced into labor, or just disappeared for any and no reason altogether. They have limited freedom of press, voting, and speech. And one of the biggest tools that authoritarian governments use to oppress the people is financial oppression, right? So if you can't spend money, if you can't buy things like food, you are really stuck. And so with the traditional finance system, it's very easy for governments to do that, to just lock you out. They can tell banks like, oh, your savings are gone. They do this all the time. Actually, it's really messed up. Imagine having, all of your money, your savings completely inaccessible to you. It's gone. It's inflated away. And then also, if you're on the outside trying to support someone who's being oppressed, they can restrict any help that outside organizations can do by just restricting the flow of money. And so Bitcoin fixes this. It helps advance these people and advance their cause and advance human rights and freedom around the world. So not only is this a fun, technically challenging, and potentially profitable project we've got going on here with Bitcoin, it has a very real chance. It is improving the world. The Bitcoin fixes this applies to the world. I really do think that that's true. And what we're doing here is important. So that's another good reason why you should care. Okay, cool. Well, all you hackers out there, you are in the right spot, I think. Excuse me. You do not need to be an electrical engineer to build hardware, just like you do not need to be a computer scientist to program. You can just jump in and do things, trust me. One of the things I think people get hung up on here is like, oh, we're going to build an ASIC, right? An ASIC is the chip inside the miner that does all the work. Sometimes people call that ASICs the machines, but it's actually, technically speaking, it's the chip. That's an industry term for a application-specific integrated circuit, which would be the chip. But we don't need to build those. It would be cool, but we don't need to. It costs tens of millions of dollars to think about starting to make an ASIC, and you're not even guaranteed success with that. So it's not very approachable, and I think getting hung up on that project would keep us from doing a lot of good work, which we can do using other people's ASICs. So don't get too hung up on the fact that the ASICs aren't open source yet. We can do a lot until then. One of the things that we do need to do, however, is convince existing ASIC manufacturers to sell us chips. Bitmain currently does not do this. They like to keep total control, and so they don't do it. But manufacturers are starting to listen. I finally got some people to talk to me, which is pretty wild after a couple of years of nothing. It seems like they're starting to be interested in this. But this is one of our jobs here, is to tell these manufacturers, yes, we will buy your chips. We will make products and sell them, with your chips in there, selling more chips for you. This is going to be a money-making exercise for them. And what we need is them to sell us brand new chips in trays with data sheets, so we don't have to unsolder them out of Antminers. Bitmain probably will never do this, but there are lots of new players, new entrants, new manufacturers in the mining scene who will. They are very hungry. They're very hungry for Bitmain's 80% lead. They see all the money there, and they want to do it. So let's use their hunger to help decentralize Bitcoin mining. Hardware hacking is an awesome skill to have. It's like digital homesteading, being able to own your entire stack, top to bottom. Like, I designed this hardware, I soldered it together, got it manufactured. There's a massive flex, not as hard as it seems. And learning how to do this is absolutely a superpower. Being able to make these things, very exciting. Highly encourage it. And then, if anyone has worked on software engineering, programming, coding for a living, it can be a little bit unclear how to make money making software. The biggest and brightest minds of our generation appear to be making money by selling ads. So that's not super cool. I think with hardware, there's a very clear path to making money. because hardware always has a cost. Like, it's physical goods, it's always going to cost something. And so you can essentially add value to it and sell. You can always sell hardware. You always should sell hardware. And you can be very profitable doing this, and it can be open source at the same time. It's almost, I think, better in that way than software, a better match for open source. All right, so let's talk about the Bitaxe a little bit. This is a Bitaxe. This is a cool artwork that was in Bitcoin Magazine. It was pretty fantastic to see that. They had it was on the cover of Bitcoin Magazine, and there was lots of pages inside on it. So it's starting to become a cult classic, maybe household name. I don't know. About the Bitaxe project, it's not a company. It is an open source project, like Bitcoin Core is. It lives on GitHub with schematics, bill of materials, board layouts, everything's there. It's all under copyleft licenses, GPL for the firmware, and open hardware license, OHL, for the hardware. This means that, it's permissionless. Anyone can build it, improve on it. You can start making Bitaxes and sell them. You can just tinker around. You can change it. You can learn how it works. It's all about the freedom, the freedom vibes here, which I think is compatible with Bitcoin. It's, I think, perhaps the first Bitcoin miner for Bitcoiners out there. We've had ASIC miners for over a decade, and this is the first open source one. I think I'm trying to stick to the Bitcoin ethos with this project. I think it's going very well because of that. And, it's a low hash rate miner. So a lot of people call it a toy because it's low hash rate, but it's a very real miner. It uses the same ASICs, the same efficiency as the big boys, and it is very capable of solving blocks. There's 2 of them that we know about that have happened in the last year and a half. It's a real miner. It's just, a small piece of a bigger miner. So let's dig into what it is, what the hardware is. It is surprisingly simple. The ASIC chip itself does most of the work here. I got a little diagram about, the main blocks of it, which there's just 3. You can see at the heart is the ESP32. That's you think control board. That's at the top there of this diagram. It's a cheap Wi-Fi enabled microcontroller. It's not anything specific to Bitcoin. These are in lots of IoT devices. You take apart your smart light bulb or your doorbell or whatever. You're very likely to find an ESP32 in there. It's probably the cheapest Wi-Fi based microcontroller you can get. So lots of support not related to Bitcoin or mining out there for this. It's been very good to us so far. One of the downsides is that it only supports 2.4 gigahertz Wi-Fi. I assume this is a cost measure. So yeah, with the Bitaxe, you got to find yourself a 2.4 gigahertz Wi-Fi. It won't work on 5 gigahertz Wi-Fi. I think so far, this hasn't been a huge problem. Most Wi-Fi seems to support both 5 and 2.4 gigahertz. I assume in the future that won't be the case, but I'm hoping that we'll get a new microcontroller in the future that can support 5 gigahertz. All right, ESP32 microcontroller, that's no big deal. Pretty easy. I think if you dig into that, you will, you'll find lots of support. There's lots of Arduino stuff, lots of hobbyist make magazine kind of thing that you can dig into with that. I would say that the most complicated part by far is the voltage regulator. That's the sort of lower left box there. This takes the input voltage, which in case of the Bitaxe is 5 volts, and it steps it down to around 1.2 volts, which is what the ASIC wants. It's complicated because it has to do this at relatively high power, like 20 watts, which is, I would say, non-trivial. Probably most of the work on the Bitaxe here was put into designing this, getting it to work properly and efficiently. It is important during that step down process to not waste a bunch of power to have efficiency. I think we're probably in the like low 90s, like 90 something percent efficiency. The cool thing here with this one, and this is a trick I learned before kind of getting into the Bitaxe and Bitcoin mining stuff, was Texas Instruments, the manufacturer of the voltage regulator. They have a tool called WebBench, and you can kind of put in your specs like, oh, I need to have support like this voltage range input. I need this output voltage at this current, this power rating, and some other details. And they'll design the whole circuit for you. There's probably about a dozen components that they'll pick out and give you the schematic and tell you the performance. And, of course, they use all Texas Instruments parts, but it is a game changer as far as getting a working voltage regulator circuit put together easily and quickly. And then there's some other glue circuitry. We've got a display, we've got a fan controller. Those things are all pretty simple stuff. I would consider that all glue circuitry. But all this is to support the ASIC, which does all the work. It does all the mining. Unfortunately, in this case, there was no documentation for the ASIC, so it all had to be reverse engineered. I hope in the future that is not the case, so we can get a proper data sheet for the ASIC. But another cool thing is that this was all designed, and this is probably relevant for people who are going to be hacking Bitaxes for the hackathon, is that this was all put together in a fantastic CAD software called KiCad. KiCad is open source, which is really unique in this field. Traditionally, you have to get software packages like Altium that cost tens of thousands of dollars a year. And, it's overly complicated, very hard to use, and very expensive and closed source. And also old and crusty, man. Altium is like written in like Delphi or something, which is some like outdated programming language. Anyways, not an Altium fan. I'm a huge fan of KiCad. It's free, open source. Go to kicad.org and you can just download it. It runs on Mac, Windows, Linux. It's professional grade software. It's really neat. In the last few years, they've really stepped up their game. I think they've gotten some contributors from industry to help the development of KiCad. KiCad.org. There you go. Thanks for the link. I hope that people will download that and start playing with it. So you can download that software. You can go to bitaxe.org and download. We have links to GitHub, and you can download the KiCad project for any of the Bitaxes out there and open it up and just start changing stuff. It's pretty fantastic. If you're not familiar with CAD software, it can be a little bit goofy learning how to use KiCad. Of course, I'm happy to help anyone answer any questions in the Discord while you're screwing around with this. There's lots of YouTube videos, tutorials, and things like that you can get going. Suspend your disbelief for a second while you're learning it. It has some CAD tool quirks, but I think once you realize all those, you'll have no problems going forward with KiCad. Oh, also, there's two official ways to pronounce it: KiCad or KiCad. Your choice, apparently. Okay, the firmware. So there's firmware running on the ESP32. That is the mining firmware. That's the application that does all the mining, and it's written in C. It's running on a lightweight RTOS called FreeRTOS. This comes from the manufacturer of the ESP32. They have a SDK for the ESP32 that includes this RTOS and a framework for how you access all the peripherals on the chip, like Wi-Fi, GPIO, serial, USB, all these things. Lots and lots of examples there from Espressif, is the manufacturer of the ESP32. RTOS, if you're not familiar, is a very lightweight operating system. It's meant for embedded systems like this. It's not running like Linux proper. It just kind of gives you some tasks and the ability to switch between tasks and get some things like timers and stuff like that. It's pretty slick. it's just a slight touch of OS, I would say, and then everything is written in C. But the cool thing here is you can hack this. People do C++ on ESP32s. They do Rust. You can do whatever you want. There's a lot of people out there banging on this, hacking on this, and so I think you'll be well supported in your efforts to hack the Bitaxe. And AxeOS is what we call our ESP miner is the firmware, and then AxeOS is the dashboard. They're all written in sort of standard stuff that you can find lots of tutorials out there. And of course, I can help you in the Discord. Oh gosh, I totally had, there is some bullet points for what I just said. Okay, so right now the Bitaxe uses Bitmain ASICs. This is not ideal. Here's a picture of a tray of brand new ASICs. This is not how we get Bitmain ASICs. Those happen to be Intel ASICs. But ASIC is the chip. You can see kind of what it looks like there. Right now, all the manufacturers of Bitaxes, they unsolder them from Antminers. There's like, there can be upwards of like 300 of these chips inside an Antminer. And the cheapest and most reliable way to get them is to unsolder them from a brand new machine, which totally sucks. It's such a hack. This is not a way to scale a project. And so this is why Bitaxe project is moving off of Bitmain ASICs towards willing partners. And that's actually, I was very excited to get this tray of ASICs from Intel. Those chips are actually, those Intel chips have been discontinued by Intel, but there's millions of them still around. They still work quite well. And so we're going to do a Bitaxe with that. Of course, we will release everything open source. But the coolest thing about this is there are data sheets for these. So we can see exactly how they work, how to interface with them, how to communicate with them over serial, things like that, things that took a long time to reverse engineer with the Bitmain chips. Still a little bit in the old world, like they want me or someone to sign an NDA to get the data sheet to look at this. Even for this discontinued chip, they very much want an NDA to see the data sheet, which is, it's too bad. I don't know. It's old world. Hopefully that will change as we move forward and as they see the money-making potential. I don't think there's any proprietary information in those data sheets that their competitors don't know already anyway. So it's not going to like hurt them to give us the data sheet. It's only going to encourage people to buy their product and to build, potentially millions of miners with their product in it. So it seems like a win-win. Hopefully that will change. One of the cool things about these new chips here is it levels the playing field a bit. Right now, China has an unfair advantage because Bitmain is based there as far as getting the chips and building these machines. So they have an unfair advantage over the rest of the world. I do not want to get into another situation where only China is making these things. So these new chips, and because they're only available directly from the manufacturers right now, who are not Chinese based, I think it levels the playing field a bit, which I would like to see. So let's talk about making a Bitaxe. This is a one slide overview of how to make a Bitaxe from scratch. It's not that hard. I'm going to just go over sort of the main details here. You'll have more questions as you go through it. Hopefully, I can answer those too. So the first thing you need is PCBs. These are, this is the green circuit board part. You want blank PCBs and you want stencils. You order these from jlcpcb.com. There's a bunch of places, but JLCPCB is the cheapest, fastest. They're in China, but they ship quickly. Tariffs aren't too bad. The things that they're going to want to order these PCBs are called Gerbers. That's an output file. Think of it as like a compiled version of the board. KiCad can output Gerbers, and I already generated them. They're included in the GitHub repo in the manufacturing files folder. but you'll get the Gerbers, and they precisely detail each layer of the board. Copper layers, insulating solder mask layers, silk screen, what the shape of the board is, and then also what the stencil looks like. So when you go to GLC PCB, select a 4-layer board and upload the Gerbers. And there's this huge long form with all these options, but the cool thing is it basically auto-populates everything with changes the defaults when you upload the Gerbers. It like detects the information from the Gerbers. So you don't really need to change anything. So you can add the boards, the 4-layer PCBs, and the stencils to your cart and get those from GLC PCB. Shipping is usually more than the boards themselves, not super expensive. Next thing you're going to need is the components. This is everything that you're going to solder onto the board. I have a thing called the bill of materials, BOM. That's in the manufacturing files folder on the GitHub repo. It's just like a CSV, and it lists out all the components. And there's these things called reference designators. You'll see it's like R1, R2, C3, C4, that kind of thing. And that's every line in the BOM, and that will match up with the specific location where that part goes on the board, and it's printed on the board too. It's kind of like paint by number, I guess. So you'll want to order the entire BOM. You can do that from DigiKey. DigiKey.com is a parts distributor. They've got all kinds of stuff. I actually have DigiKey specific part numbers in the BOM to make it even easier to order that stuff. Sometimes parts go out of stock. They come, they go. Sometimes there'll be something you can't find. Discord is a good spot for that, to ask about that. Others who are dealing with that. I cannot stay on top of it because it's like kind of a week by week sort of thing, but usually we can find some sort of solution if there's a part out of stock, whether it's a substitution or maybe you can just leave it off, or a different supplier. There's a couple others. We can help with that. There's a few other parts that you might need, like the heatsink, the fan, the display, the power supply. If you look at the README on GitHub, you can find a listing of all those parts, and a lot of it's available from Amazon. Some of it's available from AliExpress, which is like a dark alley on the internet of things from China. But hopefully, if you stick with the parts that I have specified, you'll be all right. Then you need to source the ASICs. This is the toughest thing to source by far, because like I mentioned before, there's no one who just sells brand new ASIC chips like they should in a realistic world. You can go to plebsource.com. Plebsource is a Bitaxe seller based in Texas, and they tear down a lot of Bitaxes, and they'll actually sell you, a handful of chips for you to build a couple Bitaxes. Plebsource.com, or maybe you want to tear down a whole Antminer yourself, or maybe this is like a group thing. Maybe your buddy's tearing one down, or maybe he's got a S21 Pro that one of the hash boards died, and so you can take the chips off the other two. That's the cheapest way to get them. Again, this is not an ideal process. We're looking to fix this. I think sometime this year we will switch to different chips and hopefully fix this. Okay, so now the boards have arrived, the stencils have arrived, and all the parts have arrived. You need to I have a link to all the tools and materials that you need to build a Bitaxe. I have that on the bitaxe.org. The link that Stephen just posted there, the GitHub Bitaxe.org page, has a link. It's called Building. And in that document, you can find links to all the materials you're going to need. So you get your PCBs, you get your parts, and your solder paste and your stencil. And what I like to do is take one PCB and I will essentially tape it down to the table. And you can use your, if you get like 5 PCBs, you can use them to make sort of a frame around that PCB, so it's all level. But then, once that's all taped down with just like masking tape to your table, you're going to take your stencil and put it on top of all that. And so the stencil has little openings everywhere where you need to put solder paste, and just line up the stencil so that it's, you know, exactly oriented properly on top of the PCB. So you can just see all the pads through the hole in the stencil. Get that as close as you can. Like, you want to get that right on. This is a pretty important step. So get that right on, tape that down. Okay, now you've got this whole thing taped to your table. Take your squeegee, which can be like a library card, credit card. It's a good use for a credit card if you're not using those things anymore. That's your squeegee. So you're gonna just put some solder paste on the stencil, and you're going to squeegee it, pull it across all the openings in the stencil, and squeeze it through. You want to wear some gloves for this. The solder paste that I like to use has lead in it, so lead won't hurt you if you don't eat it. Don't get it on your skin. So wear rubber gloves while you're doing this. Put it on there. Throw away that credit card. Use rubbing alcohol to clean up your work area if any got there, but do not eat it. Don't get it on your skin. Don't get it in your eyes, that kind of thing. Okay, now you're going to take off the stencil, and you've got your board here, and it's got just perfectly placed solder paste on all the pads. That's where all the parts need to go. If you messed it up, don't worry. Like, start over. You want to get the solder paste evenly and squarely put on the board. Take a paper towel with some IPA, isopropyl alcohol, and just wipe off all the solder paste, and do it again if you want. Do it until you get it just right here. This is a pretty important step. If you get the solder paste put on right, like, you're not going to have any troubles. This is going to go really, really well for you. Oh my gosh, I keep forgetting to go through my steps. Okay, so next step, I have a link to some fairly affordable tweezers, and I like to use a magnifying headset, but you're going to take the parts that are listed on the BOM and where they go, and you're going to use tweezers and just set them on top of the paste on the PCB. If you look in the Bitaxe GitHub repo, there's a file called the iBOM, or interactive BOM, and it actually opens up a self-hosted website that's an interactive tool that shows you all the BOM items, and you like mouse over it, and it highlights on a picture of the board where it goes, and you can check like, okay, I did that, because there's a lot of parts, and sometimes it can get a little confusing to keep track of where you are and what you've done. You can't necessarily look at the bare part itself and tell what it is, so it's very important to keep them in the bags that they come in, which will be labeled with what they are, so that you can get them all placed in the right spot. But basically, in the iBOM, just go down your list, get the parts put on the board, get them centered, give them a little tap, squeeze them into the paste. You're going to get it all set up there and all the parts on there. Once you've got them all on there, just on that first side, now you need to bake it. And this is kind of crazy, but I use a toaster oven for this. It works surprisingly well, like a regular convection toaster oven. Of course, you will never, ever use this for food again. This is now a soldering toaster oven, but it works really well. I've done hundreds of PCBs that worked great in a toaster oven. So I'll quickly tell you my method, but I do have it outlined in that document that I mentioned on GitHub. But what I'll do is I will put the PCB on the wire rack in the toaster oven. And then I will also take a thermocouple temperature sensor. This is just like a temperature sensor that can go to pretty high temperatures. I'll put that in there, just the probe in there, and I'll shut the door on it to kind of hold it in place. Now, I turn the oven to convection mode and turn it on to about medium. And then I'm going to look on my temperature sensor until it gets up to 140 degrees Celsius. It'll take a little bit, but as soon as it gets to 140 degrees Celsius, I start a timer for 2 minutes. And the idea is you want to keep it at 140 C for 2 minutes. It'll start to creep up a little bit past 140, so you can turn the temperature dial down a little bit to try and keep it right there. Like, I'd say 140 to 155, range is kind of where you want to keep it for 2 minutes. If it gets too hot, you can open the door a little bit and turn it down. But once your timer goes off, it's been 2 minutes. Now I crank the temperature to max and wait for it to get to 200 degrees Celsius. As soon as it gets to 200 degrees Celsius, I start a timer for 30 seconds. And you don't really have to do anything. It's going to go, you can go up to over 220, but the toaster oven is probably at its upper limit as far as temperature goes here. So as soon as it hits 200, start a timer for 30 seconds. It'll get maybe to 220 by the time your timer goes off, and then ding, turn it off. It's done. Open the door, let it cool off. It's obviously very, very hot inside, but all that solder paste will have melted, and now all your parts will be stuck to the board. And so it's just a matter of cooling it off relatively slowly, but it's soldered. Everything will be soldered on the side. It's fantastic. If you probably have a glass door on your toaster oven. It's really cool to look in and see. You can watch like right when it starts to hit like 200, 210, all the solder paste melts and the parts have this like surface tension and they'll just like ding, like snap into position. If you had them slightly misaligned, they'll just snap right into position. It's magic. So that's all done. It's cool. Take it out. Now you have to do the same thing to the other side. It's a two-sided board. There's parts on both sides. So start, over at step 5, redo it, use your tape it down, tape the other stencil because you got 2 stencils, one for the front, one for the back. Tape the other stencil on there, put the paste, put all the parts on, put it in the toaster oven. A lot of people are like, wait, like all the parts are going to fall off that are now on the bottom when I have the board in upside down. It's so crazy. They don't fall off. It's really wild. They'll stay on. Solder the second side and you are done. You just built a double-sided SMT PCB, which is pretty cool. Take a good look at it. If you did a good job spreading the paste on there won't be any problems. But if there might be a little bridge or one of the parts may have like lifted up or something. It's not too hard to correct that with a soldering iron. You can just get a basic soldering iron and maybe a little bit of flux. I have links to these things in the document, but you can touch those things up pretty easily. All right. That's the one slide gist of how you assemble surface mount parts. It's not too bad. So why would you even want to do this? Like, what the hell? I think I went over some reasons why you might want to contribute to open source Bitcoin mining, but it's addictive. It's really exciting. It's really fun. It's a cool technical challenge. It's a cool like hobby thing to work on and hack. Now you can start changing things. You can start contributing to the project. You can make your own thing. This does contribute to decentralizing Bitcoin mining. It absolutely does. The more people that we know, the more people that know how to do this, the better. The better off Bitcoin will be, the better off you will be as Bitcoiners. You learn just insanely cool skills. Maybe I'm biased. I don't know. I really think this is cool. This is good stuff to know how to do hardware, firmware, reverse engineering. It's a rad community. You can participate in super cool hackathons like this. Like this kind of thing has been accelerating at a crazy rate. Like people are getting more and more excited about this. Businesses are starting up. This is a fantastic thing to be involved in. The community is super cool. Everyone around this is super rad. You meet lots of, very smart people, very helpful people, very curious people, smart people. It is super cool. And this is, it can be a hobby, but it can also be profitable, right? You can build these things, you can improve on them, you can sell them, you can do this. And you can make money doing it. Definitely lots of money. There's lots of money to be made selling Bitcoin miners. So let's fucking go. Let's get started. You can check out the Bitaxe project website at bitaxe.org. There's a link to the GitHub, which Steven posted the GitHub link there. We have a Discord, OSMU. You should check this out. It's a very big, there's like 9,000 people in there. It's a very big, very busy Discord, but lots of smart people in there are kind of following along. Lots of people to ask questions, answer questions, things like that. There's a link to our Discord on there. Of course, there's a Discord for the mine hackers, and join that one too. So you'll have Discord open a lot. Download KiCad, start poking around, hack, share your designs, decentralize Bitcoin mining. We can do this. We've got to do this. So that is my my talk here, but I wanted to, in our, I guess, final minutes here, go over what some cool project ideas, something to inspire you on things to build, things that I thought were cool. This is a pretty neat design someone did with hydro cooling. The Bitaxe normally comes with a fan. They were like, oh, we put on a water block, we put on a pump, put on a radiator, and if you look closely at the screen there, you can see this is a Bitaxe Super, which is nominally like 750 gigahash, and they have it well over 1,000. So they're overclocking it. Pretty cool. I think there's some exciting things to be done there. Maybe you could make new water blocks if you're mechanically inclined like that. This I thought was really cool. Someone just strapped their Bitaxe to the hot water pipe, which it took me, I was thinking about, why do they do the hot water pipe? But it makes sense. Basically, you just need a large thermal sink to dissipate that heat that you can just dump heat into. Residential hot water is like 48 degrees Celsius, which is actually kind of cold compared to what an ASIC wants to be at, which is like 60 to 70 degrees Celsius. So I assume you could dump heat into the hot water. Why not the cold water pipe? I don't know. Play around with that too. Maybe there's a condensation issue, something like that. Seems like some cool things to be done there. Okay, so this is a cool one. This is, I think, going after unique power sources, right? The Bitaxe is a low voltage DC device. Bitcoin mining ASICs are fundamentally low voltage DC devices. So are solar cells. They're both fundamentally low voltage DC devices. Solar cells are the building blocks for solar panels, just like ASICs are the building blocks for miners. There's definitely some synergy here. Also, most miners have an AC to DC power supply. They plug into AC, higher voltage AC in the wall, and they convert that to DC. Well, that is pretty inefficient. Doing that process, you waste energy in the process. So just cut out the middleman. Just skip that. I think direct DC is a very exciting avenue to take for Bitcoin miners. The Bitaxe is a shoe-in for it because it accepts 5 volts DC right on it. There's also models that do 12 volts DC. Cut out the middleman. Pretty cool. And I don't know how we're doing on time, but I wanted to talk about a project that I've been thinking about for a long time in this vein that maybe I can get some of you excited about doing. So I think powering Bitcoin miners directly from solar panels is a very interesting field. It's actually how I got into this. This is what I wanted to do initially before I made the Bitaxe. It's why I made the Bitaxe, because there was no miner that I could hack on to do this project. Never ended up doing it. I still think it's a cool idea, but imagine having a solar panel with a Bitcoin miner strapped to the back of it, and it's powered directly from the solar panel. It's totally wireless, right? You have wireless data, wireless power. You put it out in the sun. It starts mining as soon as the sun comes up. It stops mining when the sun goes down or when a cloud goes by, and it just automatically starts going. You can kind of just place these things out in the yard in range of Wi-Fi, or maybe do it on cellular or whatever. There's a couple gotchas though. Solar panels are not ideal power supplies. So there's a technique called maximum power point tracking that you need to use to extract the maximum power from a solar panel. And what it's called MPPT, and what it is an algorithm where it's constantly testing the solar panel to see if it's at its maximum power output. Because you have to remember, solar panels are out in the sun. The sunlight or irradiance is constantly changing throughout the day, different seasons. There will be, for any given irradiance, there will be a voltage and current output that extracts the maximum power from the panel. And so MPPT is an algorithm to constantly test and find that maximum power point. Now, normally this is done to charge batteries with solar panels. That's what most solar panels are used for, is to charge batteries. Well, we don't want to charge batteries. We don't actually have any use for batteries. Batteries are expensive and they are also inefficient. Like charging them up only to discharge it later, you get less power out. And so there's inefficiencies there. What if we could skip the battery and attach the solar panel to the miner directly, so that when the sun comes up, it starts mining. When a cloud goes over, it drops down its hash rate. When a bird shits on the panel, it just reduces its hash rate. And then it automatically, adapts to whatever irradiance is available. And I think we could do that by, instead of doing what MPPT does, which is adjust the battery charge current, we could adjust the hash rate. So instead of, we're not even charging a battery, that's not even in the mix, we can adjust the hash rate of the miner. And this will, in effect, adjust the solar panel's output voltage and current to keep it right in that maximum power point. So they're always hashing at sort of the maximum hash rate that we can be for any given irradiance and solar panel configuration. You might have to have a little tiny bit of energy storage in there for the problem where the sun just goes away and there's no power available whatsoever. You need to ramp down the miner, turn it off. You don't want to get in a situation where you're always trying to, as soon as any power is available, you're trying to turn on full blast, because that will crash the panel and it'll get stuck where it can't output anything at all. So you need a little bit of energy storage in there to kind of run the administration of the system while it's trying to figure out where it is to run that maximum power point tracking algorithm. I like to call it maximum hash point. But yeah, I think that's a cool project. I think that it'd be really cool to do some solar stuff with this. Some people have been working on this. If you check out OSMU, check out Twitter, there's some projects with solar. Once you get it set up, it's free power, $0 per kilowatt hour cost. Pretty cool. Okay, this is my last one, I promise. Big power sources are nice, but they are expensive and very centralized. You can't just move this dam or move your gigantic Bitcoin mining farm when regulation or water flow or whatever requires it. So what if we went for more smaller power sources? This is kind of the home mining strategy, right? Instead of finding a nice cheap source of power like this huge ass dam in Canada and locating there, what if we just located them in everyone's house? I found this crazy stat this morning that in the US, phantom power, meaning once you've unplugged your phone from the charger, but the charger is still plugged into the wall, that's phantom power. Like, it consumes a little bit of power just to have your charger plugged in, even though it's not charging your phone. That's called phantom power. Like, a lot of electronics do it, like TVs, I don't know, air conditioners, all sorts of things. There's just like this sort of, they call it quiescent power, this baseline of power that they'll draw at any given time. Well, if you add up all the shit we have plugged in the US, that is 20 gigawatts, supposedly, which, at the low end of the estimate here, that could power 105% of the current Bitcoin mining network. So just the phantom power in the US, supposedly, theoretically, could power 105% of the global Bitcoin mining network. That's nuts. That's absolutely crazy. This is electricity that we're paying for. You have to pay for the electricity for phantom power in your house. But we don't care, obviously. Like, we don't go around unplugging our cell phone chargers because it's costing so much. This is just sort of trivial power, but in mass, it adds up to a significant amount. So, what if we made a Bitcoin miner that was also a cell phone charger that turned off Bitcoin mining when you're charging your cell phone or something like that? So it's just the, 99% of the time that it's sitting around plugged in your house, it's just there mining. That creates an extremely decentralized, extremely resilient Bitcoin mining network, right? Because you're not a massive Bitcoin farm. You're not a publicly traded company that's like a sitting duck for regulation. You just got this little box plugged in at your house. No one's going to know you're running it. You're not going to turn it off when the Bitcoin price changes. You're going to forget about it. But this could, this could add up to be a very, very large part of the Bitcoin mining network. So I think that, it'd be cool to see folks going after that, creating, little miners looking for these sort of weaselly little stranded intermittent power sources, because there's lots of them. There's lots of them, and there's lots of people that are doing it. So that is basically what I got going here. I think we could do some questions. I have 2 other projects that I could show if you think there's time.
Yeah, sure. We got time. There's no hard cutoff here. It's just a live stream here.
Okay. Let's see. I want to switch over to a different screen. Let me figure out how to do that. All right, hold up. I need to open this up in another window. All right, there we go. Can you see that?
Let's see. I think I have to add it. Yeah, there we go. Yeah.
Cool. All right, I need to switch to that one. Okay, cool. This is another little project. This is something I've been just goofing around with for a while. It was kind of like a side effect of the Bitaxe project. It just sort of fell out of the reverse engineering work that I did on that. But it's called the Addit board. And I just released a new version of it. But this is a tiny little dongle. I've got one here. I'll hold up in front of the camera. Tiny little dongle. And it plugs in, it converts a Antminer hashboard to USB. Which I think is pretty cool. So normally, if you wanted to use an Antminer hashboard, you have to use those big ribbon cables and you have to plug it into a control board that supports it. This removes that. There we go. This removes that need. You can make a hashboard USB. So you got to provide your own power for some power source. You could do that from an APW3, one of the S9 power supplies. You could use an S19 power supply, whatever, right? You just got to get like 12 to 15 volts there. But this for data means you can plug in this little dongle into the hashboard, and now it's a USB port. And so you can plug that into your laptop. You can plug that into a Raspberry Pi. And you can write mining firmware on your PC using Python, using Rust, using whatever you feel like. You could do it in JavaScript if you're like just totally masochist. So actually, it'd be kind of cool. Imagine a mining firmware that's a website. I think that could work. You could do like, was it like web USB or web serial, which could then talk to this, and you could have a website that is a mining firmware that's mining to your connected hashboard.
Would that be different than something like Public Pool, which is like a TypeScript version of Stratum V1?
It would be very similar to that, actually. I mean, Public Pool is the Stratum server side, so you would need to make the Stratum client, or I guess you could combine it all and just connect directly to your node.
This would be like a website that talks directly to the mining hardware.
Yeah.
Nice. Okay.
Right. I mean, there's, they call it universal serial bus for a reason. It's very versatile, and I think I wrote so this has a microcontroller on it. The Addit board has a microcontroller on it, and I linked on this GitHub repo. I have some firmware that you can load onto that, and that just makes it a pass-through serial device. So whatever bytes you send over USB to the will be sent out over the connector to the hashboard. And we have good examples of what bytes you'll need to send in the Bitaxe firmware. So I think this opens up a lot of possibilities for hacking, heat reuse stuff, making use of salvage equipment, I guess.
Oh, very cool.
Yeah, and then there's one other thing. So yeah, got the URL for that there. That's at my GitHub thing. It's called the Addit board. All the source files are there. You can actually have JLC PCB totally solder this whole thing together for you if you want to do that, and they'll just mail you back like the completed thing. You can load the firmware on there, or you can hack it in KiCad. I got one other. So this is a related project. This is a hat for a Raspberry Pi that allows you to control an Antminer power supply and 4 fans. So if you wanted to get rid of your control board on an Antminer and replace it with a Raspberry Pi that's connected to 3 Addit boards, you could use this hat on top of your Raspberry Pi to control the fans. You're definitely gonna need fans. These things will overheat otherwise. And then the power supply, this little connector here is for the power supply. So these Antminer power supplies, they have a data connection, and you need to tell them to turn on and what voltage and et cetera. And then this bigger connector here, that is the power connector for a traditional Antminer control board. So then you can power the Raspberry Pi and the Ant hat from your power supply that would normally be powering your control board. So this and the Addit boards is sort of a replacement for a Antminer control board, and it gives you the ability to write some crazy ass software and do what you want. Like add Wi-Fi. This will if you use a Raspberry Pi, this will have Wi-Fi built right in. It'll have Bluetooth. You can take any of the insane Raspberry Pi projects that are out there, like a touchscreen display, or there's like limitless what you can add. So
I could take like an Antminer and take all the hash boards and like just take the control board that's already in there, take that out, and like replace that with like a Raspberry Pi or something like this.
Yeah. That's exactly what this is.
Oh, that would be cool.
And control boards are notoriously hard. Like they're computers that are running Linux, but they're notoriously hard to use and to load arbitrary code on.
Yeah.
That's not the case with a Raspberry Pi, man. It is easy. You just like SSH into it. You could write Python right on it if you want.
Is in terms of like if somebody did make like an operating system for a Raspberry Pi minor control board, when you're like interacting with the hash board, is this like a known problem space? Like, do we know what kinds of commands and electrical signals to send to these hash boards, or is it like something proprietary that's going to require a lot of fiddling and hacking to make it work?
So there's a bunch of different Antminers out there. They're not all the same.
Mhm.
The more recent ones, like the S19, K Pro, some of the J Pros, the XP, the more recent ones, you don't need to do anything. Like you just give them power and they turn on, and you can send data to the whole chain of ASICs. And so you can look at the Bitaxe and see how that's done. And there isn't much hand holding that you need to do. A lot of the times when you've heard of the Loki board, which allows you to use different power supplies and it kind of hacks it. That's dealing with the stock firmware and the sort of control that it places on you. Here, we're not dealing with any of that firmware. You're writing your own. So yeah, in summary, the newer Antminer hash boards need less handholding. Some of the older ones, you had to communicate with a PIC that was on the hash board, and you had to like actually enable power. And I believe there was like a watchdog where if you didn't feed it, it would like turn off power to your hash board.
Oh.
That's going to be on the S19s, the older J Pros, and of course the S17, things like that. I would probably just avoid those unless you're into figuring that out. Some people have, but I have not. So I would recommend getting a newer one if you're going to do this.
Got it. Well, cool. I took some screenshots of your presentation there, and I was going to drop these in the Discord here as like uh, project ideas that people can see, and they can go to the video and watch this, or ping you to learn more about these.
Cool.
Um,
Cool.
oh, one question I had too before we wrap up. You mentioned when you're baking the Bitaxe in the toaster oven, and like the kind of high temperatures you're using there. I guess I think of usually like circuitry, like I worry about like overheating a computer or something like that. Is that a concern when you're trying to cook the solder in the toaster oven?
Don't go much above 220. If you look in the data sheets for any of these parts or the spec sheet from the manufacturer for the PCB, they'll have a maximum temperature listed. And this whole thing wouldn't work if they couldn't handle the solder melting temperature. So that they all by necessity will need to support the solder melting temperature, which is like 220 kind of thing. The these max temperatures are different than the max operating temperatures, which is what I think you're probably thinking of, and
Uh,
that's more in the like 100 degrees Celsius. Uh,
and that's just more like it's just not going to behave properly and do its job as a piece of computing hardware at that temperature.
Yeah, yeah. Especially if you're like running current through the part, you might find the transistor goes into thermal runaway and now it's conducting more and more current and it can like burn itself out from the inside. But when you're reflowing a circuit board, it's off. You're not running any current through any of it. So it's just the plastic essentially is what needs to be able to withstand that temperature. And it can.
Uh, I see. Yeah, just like the stuff on the outside. It's different than having it like kind of in this ambient hot environment that's different than like actually running a bunch of electricity through it where it's going to heat up from the inside.
Yes, exactly. Exactly. Yeah. I mean, this is how all circuit boards are made. Obviously, not in a toaster oven, in a more sophisticated oven, but reflow is very common. And the temperatures that you need to use are a function of the solder paste. It'll have a curve, a reflow curve with those two, like usually like 140 and 200 mentioned as the first phase is the soak phase. And then there's the actual reflow where the solder paste melts. Those will be called out in the solder paste. The temperatures that I use are for the solder paste that I recommend. If you get like an unleaded solder paste or something else, there'll be different curves there. But yeah, it's all designed to work like this.
Awesome, awesome. Well, I don't see any questions in the chat here, but if anybody wants to ask anything who's watching this later, you can find Scott in the OSMU Discord or the ATL BitLab Discord. Um, and yeah, I'm looking forward. I'm hoping people start hacking on some hardware in this hackathon. We've already got some people on the channel talking about doing some stuff with Blockstream satellite and like MeshNet and stuff like that. Um,
Nice.
so I'm hoping to see some also, more people jump in on the hardware side of this as well. So
Cool. Well, I guess as a reward for people that have watched till the end here, I do have some free bit access available for people who are
okay,
hacking on this. Hit me up. I have a limited number of them available. They were made, it was a kind donation from someone in the community to make bit axes available to developers, of which if you're hacking on this, you are. So yeah, hit me up on Discord and I'll give you a coupon code for a free bit axe.
hey, that's awesome. Thanks so much for providing that for the builders. Yeah, thanks so much for taking the time to give this presentation. And we'll go ahead and wrap it up there. But yeah, like I said, anybody, if you want to talk to Scott, find him in the Discord. And you have a great rest of your day.
Right on. Thanks, guys. Looking forward to what you're going
All
to
right.
hack on.
See ya.